Good morning, one and all. Welcome back to video lecture series of signal systems. This is Dr. P SREENIVASULU. Today, we are going to discuss about introduction to jet transform. Now, so far, we have discussed about Laplace transform, Fourier transform, Fourier series, all these things. Now, coming for jet transform, it is just counterpart for Laplace transform. Jet transform is a discrete counterpart of Laplace transform. So, simply, the meaning of this one is whatever the Laplace transform performs in continuous time signals, whatever the Laplace transform performs in continuous time signals, the same concept, it is going to be performed in discrete time signals. So, the Laplace transform, whatever the problem is overcome by Fourier transform, that is also done jet transform in discrete domain. So, if you see the discrete time Fourier transform, dt of t, this dt of t is applicable only for stable signals. The dt of t is applicable only for stable signals. Suppose it is a unstable signal. Suppose we are considering a discrete time sequence. It is an unstable sequence. Again, discrete time Fourier transform fails. So here, whenever the discrete time Fourier transform fails, then we go for a jet transform. That is the first thing. Second thing is, whenever there is a difference equations, there in the time domain, we are going to call differential equations because it is a continuous time. Here it is a difference equations. So whenever if you want to solve the difference equations, now we can easily solve by using this jet transform. And this jet transform, the main purpose of learning the jet transform is analysis of discrete time signals and systems. We can easily analyze discrete time signals and systems. Next, digital filter design also. Whenever there is a FIR filter, we can use this jet transform for delay purpose or advanced purpose. Next, digital filter or system synthesis. So these are the main purpose of learning this jet transform. So a very easy process, jet transform. Now you see this jet transform. Generally, it is a block diagram, a simple block diagram, jet transform. The input is here. So far, we have given the input is x of t because these are all continuous time. Now we are going to discuss about a discrete time. So we are going to show the difference. It is a x of n. X of n jet transform is x of jet. Okay. Now, what is the definition of jet transform? First of all, you see the definition of jet transform. See the simple formula. X of jet is jet transform of x of n. It is equal to x of jet. It is equal to summation of n equal to minus infinity plus infinity x of n into jet power minus n. Similarly, like in Laplace transform, here also there is a two types: bilateral Laplace transform, unilateral Laplace transform. Bilateral Laplace transform, we are going to be consider initial conditions are 0. So even there is some initial conditions, we need to consider we are going to be neglect these initial conditions in bilateral Laplace transform. While you are coming for unilateral Laplace transform, unilateral jet transform means it is going to be started from n equal to 0 onwards, n is equal to 0 to infinity. Whenever there is some systems, it requires some, suppose if we want to analyze some networks or some systems in discrete time, we need to know some initial value about this one. This initial value concept is obtained from unilateral jet transform. We will see later about this unilateral jet transform. Coming for this jet transform, in general jet transform, we have a formula. While coming for inverse jet transform, there is no fixed formula here. We are going to be obtained from the 4 different ways. One is this long division method, another one is partial fraction, another one is residue method, another one is convolution, general convolution formula. So first of all, we see jet transform, and then we were going to see this unilateral jet transform and inverse jet transform. You see here, suppose it is a unilateral Laplace, unilateral jet transform. You see this one, n equal to 0 to infinity. Suppose it is a bilateral Z transform, both for n equal to minus infinity to plus infinity. So that is the difference between unilateral Z transform and bilateral Z transform. Now, there is a very important point. This is a region of convergence. It is a very important point. Like Laplace transform, here it is very important point. Because here also the Z transform, it is not going to be applied for entire unstable sequence. For entire unstable sequence, it is going to be obtained up to certain range of values of R here. There up to certain range of values of sigma. That is the difference between R. Here Z is equal to generally R into e power j omega. We are going to represent this Z value R into e power j omega. Whenever we are going to be write magnitude of Z, whenever we are going to write magnitude of Z is equal to R magnitude of R into e power j omega. You know what is the magnitude of e power j omega? It is a 1. So we are going to write magnitude of R. What is this R here? This ROC here in the Z transform, we are going to be represented in the form of circles. In the form of circle. That is also here a radius of the circle. Remember, the ROC is going to be represented in the form of circle. The R is here, Z is equal to R into e power j omega. Whenever we are going to be calculate magnitude of Z, it is equal to magnitude of R. So it is going to be right radius of the circle. So here the ROC, suppose the sequence is right-sided sequence. Suppose the sequence is right-sided sequence. The ROC must be above the circle. The ROC must be above the circle. He has given three conditions here. You see here, ROC gives an idea about the values of Z for which Z transform can be located. Next, ROC can be used to determine causality of the system. ROC can be used to determine stability of the system. If you apply this concept for systems, we can obtain, calculate stability from the ROC. We can calculate causality from the ROC. Now, the idea, whenever it is a sequence is a right-sided sequence, my point is the ROC must be outside the circle. Suppose the sequence is left-sided sequence, the ROC must be inside the circle. Suppose the ROC is the signal considering the sequence considering both right-sided and left-sided, the ROC in between the two concentric circles. Like that, there is a ROC concept is there. Now, if you want to see some Z transformer, some sequence. Now, if you see here, it is a x1 of n. We have the sequence 1, 2, 3, 4, 5, 0, 7. So here the arrow indicates it is the x of 0. At x of 0, the amplitude is 4, and x of 1 amplitude is 5, x of 2 amplitude is 0, x of 3 amplitude is 7, x of minus 1 3, x of minus 2 2, x of minus 3 1. So these are the identification of sequence. What is the n, whether it is a 0 or 1 or 2, like that. So based on that, whenever if we apply formula, the length of the sequence you need to visualize. Now, if you see here in the first sequence, there is a two cases. In the first sequence, he has not given any arrow. He has not given any arrow. Suppose he has not given any arrow, defaultly you take first one is a 0. So that's why you observe the first sequence. x1 of 0 is 1, x1 of 1 is 2, x1 of 2 is 3, x1 of 3 is 4, x1 of 4 is 5, x1 of 5 is 0, x1 of 6 is 7, like this. Similarly, x2 of n, previously whatever I have said, whenever there is a arrow, it indicates that n equal to 0. Left sided that one is negative, right side of that 0 is positive. Now here there is a formula is from n equal to minus infinity plus infinity. But the sequence is available from 0 to 7, 0 to 6, I think. 0 to 6 or 0 to 7. So 0 to 6. 0 to 6 or 0 to 7? 0 to 6. So you can write the formula x1 of z is equal to Laplace z transform of x1 of n is equal to x1 of z is equal to n equal to 0 to 6 x1 of n into z power minus n. If you substitute that sequence, x1 of 0, x1 of 1, x1 of 2, x1 of 3, x1 of 4, x1 of 5, x1 of 6, like that, we substitute all this, whatever the sequences we have. Now, that corresponding amplitudes you substitute here, and that z power minus 0, z power minus 1, z power minus 2, z power minus 3, z power minus 4, z power minus 5, z power minus 6. Now, if you write these powers from negative powers to positive power, the z transform is like this: 1 plus 2 by z plus 3 by z square plus 4 by z cube plus 5 by z power 4 plus 6 by z power 6. Now, coming for ROC, if it is z is equal to 0, if it is z is equal to 0, or 1 by 0 infinity, so it is not going to be exist. So from that we can write the ROC is entire z plane except at z is equal to 0 for first problem.